All right, so we are back. Now we're talking about angle, angle, side, angle, and HL in proofs. So the idea here is that in your proof, you need to catalog every single piece. So if you're using angle, side, angle, you need to put in your proof somewhere angle 1's congruent to angle 2, then angle 3 is congruent to angle 4, and then this side's congruent to that side, so that you have two angles and a side cataloged. Then you can say angle, side, angle, or angle, angle, side, whichever one's appropriate. So let's take a look at this example here. It says given angle G is congruent to angle I, so let's mark that up. FH bisects angle GFI. So angle GFI just got cut in half, which tells me that that angle is congruent to that angle. So that's our full given. So let's go ahead and type that in as our reason. So then step 2 says angle GFH is congruent to IFH. Well, that's what we just said. GFH is congruent to IFH. So those two angles are congruent. And the reason I know that is definition of angle bisector. So the next step asks, what do we know by the reflexive property? Well, the reflexive property is used when something is congruent to itself. So I can say that FH in the top triangle is congruent to FH in the bottom triangle. So FH is congruent to FH. Now, if I take a look at what I have in the diagram, I have two sets of marked angles and then a side that's not in between those two angles. So I can say that triangle GFH and there's no symbol for a triangle on this program, so I just have to write triangle, so I'll abbreviate that tri. So triangle GFH is congruent to triangle IFH. And the reason I know that's true is by angle, angle, side. So I've successfully proven that the two triangles are congruent by listing all three pieces that I need and then saying they're congruent by angle, angle, side. Let's try another one. So here I know that ST is parallel to RU. And so what does that mean? All right. Well, as soon as I see parallel lines in a diagram like that, I automatically start looking for alternate interior, alternate exterior. And I think since those two lines are parallel and here's my transversal, RT, I would know that this angle up here is congruent to this angle down there. So let's go ahead and get back to our proof and see what all we can put in there. So ST is parallel to RU. That was given to us. And then it wants us to say something about if lines are parallel, then alternate interior angles are congruent. So which two angles were they? It was angle STR is congruent to angle URT. Okay, so far I have logged in my proof one set of congruent angles. Let's take a look at what else it says. It says that SR is parallel to TU. Again, that was given to us. So let's mark that up in the diagram. So SR is parallel to UT. Now I'm using a different color here because there's something I want you to pick up. Okay? Because those two lines are parallel, then I can say that that angle is congruent to that angle. So what will happen sometimes when we have a situation like this where they tell us, the top and the bottom are parallel, the two sides are parallel, Some people will say, oh, well, if these two sides are parallel, then these two pink angles have to be congruent. And they mix up which angles are congruent based off the parallel lines. So I color-coded them so that you can very clearly see that when the top and the bottom, the pink lines are parallel, those pink angles are congruent. But when the two sides, the green sides, are parallel, then you know that these two green angles are congruent. So make sure you know which angles are congruent based off of parallel lines. So how did I know that angle SRT was congruent to angle UTR? Well, because they're alternate interior angles. All right, so far I've got cataloged one set of parallel or congruent angles and then another set of congruent angles. So far I've got angle, but I don't have anything else just yet. But if I take a look at the diagram, the two triangles share a common side. So I know that RT in the top triangle is congruent to RT in the bottom triangle. So I can say that RT in the top is congruent to RT in the bottom. And the reason I know that's true, that's the reflexive property. So now I have cataloged in my proof one set of angles, two set of angles, and a side. Now, is that side in between the pink and the green angles? You bet it is. So that's going to be angle, side, angle. And I can say triangle SRT is congruent to triangle UTR. And that's my proof. So hopefully the more you do these proofs, the easier they get. It's kind of hard to catch on to, but once you kind of get the process, it's not too bad. So if you guys have any questions, please feel free to email me or ask in class, and I will see you guys real soon.